compass heading and deviation are given to you. What is variation? So simple, let's write this. True direction, variation, magnetic direction, deviation and compass direction. Now fill this information. True track 180 degree. Okay, compass heading 195 degree. Deviation -2, that means 2 degree west. Calculate variation. Okay, now this is, we are talking about true track and compass heading is given. So track and heading are different things. So with the help of true track 180 degree, drift 8 degree right, we will calculate true heading. Okay, so this is not true heading, this is true track. So how will you do that? Now, if drift is right, right drift means starboard drift. If it's starboard drift, the heading is less than track. Now what is heading here? The heading here is not known to us. Drift is 8 degree right, track is 180. So heading will be less than the track 180. So heading will be 180 plus 8, that is 188 degrees. 188 degrees. So true heading is, correction, less than drift. So it will be minus. So 180 minus 8 is 172. 172 degrees. So true direction 172, compass direction 195, deviation 2 west. Now next step. Step number 3. Deviation west, compass is west, meaning compass direction is more than magnetic direction. So magnetic will be less than compass. So 195 minus 2 is 193. Now next step, we have true direction 172, magnetic direction 193. So we can see here that magnetic direction is more than the true direction. Now magnetic is more than true only and only when variation is west, right? Variation west, magnetic is best, meaning magnetic direction is more than true direction. So what will be the variation here? 193 minus 172, 3 minus 2, 1, 9 minus 7, 2. That will be 21 degree, 21 degree west. Variation west, magnetic west. So correct option is option alpha. Next, question 42. Aircraft at flight level 370, meaning 37,000 feet, is required to commence descent at 120 miles away from a VOR and to cross the VOR facility at 13,000, flight level 130. That means you are at 37,000 feet. From 37,000 feet, you have to come down to 13,000 feet directly over the VOR station. Ground speed is given to you. You have to calculate rate of descent. So, your aircraft is here. VOR station is here. Okay. So, VOR station is this. So, from flight level 370, you want to come down to flight level 130, right? So this is your aircraft here and you want to come down to this level over here, correct? Now you have to calculate rate of descent. What is rate of descent? Rate of descent is change in level. Okay, change in level means altitude, flight level, whatever, divided by the time taken to change that, right? Time in minutes, change in terms of feet, time in terms of minutes. So our rate of descent unit is feet per minute. So according to this formula, the change in flight level here is equal to 37,000 minus 13,000. 37,000 minus 13,000, that is equal to 24,000 feet. So we have the numerator with us, rate of descent equals to 24,000 divided by time in minutes. Now we do not have time given in the question, but we have been given speed, which is speed is what, 288 knots. Speed is 288. We have also been given distance. What is distance? 120 nautical miles, right? So an aircraft is, that means this aircraft is 120 nautical miles from this VOR station. So time will be equal to distance divided by speed, 120 nautical miles divided by 288. So 120 divided by 288 is 25 minutes. 25 minutes. So substitute that here, 24,000 divided by 25. So 24,000 divided by 25 is 960 feet per minute. 960 feet per minute. So option A will be the correct option. 43. An air data computer. In air data computer, aeroplane altitude is calculated from what? Okay, so aeroplane altitude. Altitude is shown by a altimeter. Altimeter is nothing but your pressure instrument, and it works on what kind of pressure? It works on static pressure. So, measurement of absolute barometric pressure from a static source on the fuselage, measurement of outside air temperature, measurement of elapsed time for a radio signal transmitted to the ground surface and back. So correct option is option A. Static pressure comes from the static source. Question 44. The pressure altitude is the altitude corresponding to what? Now pressure altitude is the altitude or vertical distance indicated by a altimeter when you set standard pressure setting 1013 in the altimeter setting window. So that standard pressure setting 1013 happens to be in ISA atmosphere, International Standard Atmosphere. So it is the altitude corresponding in standard atmosphere with reference pressure in ambient atmosphere. In ambient atmosphere to the pressure prevailing at this point at your present location. In standard atmosphere to the pressure prevailing at this point. So correct answer is option Charlie. Okay, pressure altitude is the altitude corresponding in standard atmosphere. So maybe now you're flying in particular warm air mass. This warm air mass is warmer than ISA conditions. So you accept you're not flying in ISA conditions, but still you may be flying at 5,000 feet in that warm air mass. Now when you change your local altimeter setting QNH from QNH to a standard pressure setting 1013, the pressure altitude indicated by your altimeter will be different from the previous altitude that it was indicating with QNH in its pressure setting window, right? So whatever vertical distance it shows with 1013 in the pressure setting window, that vertical distance, that pressure altitude is with respect to standard atmosphere, okay, to the pressure prevailing at this point. Question 45. At sea level, on a typical servo altimeter, the tolerance in feet from indicated altitude must not exceed what? So correct option is option plus minus 30 feet. Now here the keywords are sea level, servo altimeter, okay, and tolerance in feet. So if you check this chapter, your Oxford instrument Altimetry, will find that over here tolerance is page 60 Oxford Instruments book. So you have tolerances given for different altimeters. Typical simple altimeter, sensitive altimeter, servo altimeter. So as you see, as you go from simple to sensitive to a more advanced servo altimeter, the ranges of this particular altimeters increase from 35,000 to 80,000 to 1 lakh feet. Okay, so the working capacity increases and also the tolerance limits become more and more accurate. So for a simple altimeter at sea level, the tolerance is plus minus 100 feet. For sensitive, it becomes more accurate than that, plus minus 70. For servo altimeter, the tolerance limit becomes even more sensitive, only and only plus minus 30 feet. So remember all the tolerances at sea level. Next. The indicated altitude on board an aircraft flying in the atmosphere, where all the atmosphere layers below aircraft are cold, is what? So always remember I have covered this in detail in in a separate video where I have covered altimetry errors, and in that I have explained how altimeter behaves, how an altimeter behaves when you fly in a warmer than ISA air mass, colder than ISA air mass, in higher pressure atmospheric region, lower pressure region, right? So your altimeter is exposed to barometric errors and temperature errors. So I have explained everything in that particular video. So do watch that video. You will find that video in the Altimetry playlist. I have also solved questions from Oxford Meteorology Altimetry chapter, back questions. So all these back questions are with respect to this theory, pressure error and temperature error. So your concept will be very much refined when you watch that video. I will explain this in short. Now altitude indicated on board, that means indicated altitude when you are flying in colder air mass, what is it? Is it equal to your true altitude? Is it equal to true altitude, less than true altitude, more than true altitude? What is it? So here real altitude means true altitude. Okay. So remember, whenever you are flying in colder than ISA air mass, colder than ISA air mass, the true altitude of your aircraft is less than indicated altitude. Okay, is less than indicated altitude. Next, when you are flying in an air mass than which is warmer than ISA atmosphere or ISA air mass, what happens? The true altitude of your aircraft is indicated more than indicated altitude. Okay, so remember this point. So over here, if you are flying in an air mass which is cold, what will happen? The indicated altitude, the altitude indicated by altimeter, will it be equal to standard altitude? It will be less than that. It will be more than the real one. So the correct answer will be indicated altitude will be more than true altitude. So higher than the real altitude, option Charlie. That means, what does that mean? So your altimeter indicates, let's say your altimeter shows or indicates you're flying at 10,000 feet, but your true altitude, or in reality, your true altitude or the real altitude will be much less than that. Let's say 8,000 feet. So actually you are flying at a lower altitude. Your plane is actually flying at 8,000 feet, but the altitude indicated by altimeter is 10,000 feet. So you are flying under a mistaken belief you are flying at 10,000 when that is not the case. So actually your altitude is 8,000 feet. You may be flying very close to obstacles, mountainous areas, whatever. So it creates an unsafe situation, unsafe condition. So remember this. Okay, question 47. What is the true altitude of your aircraft if indicated altitude is 16,000 feet and temperature is minus 30 degrees Celsius? So your true altitude, the true altitude of your aircraft depends on first atmospheric pressure. If atmospheric pressure is higher than ISA, lower than ISA, again your altimeter will be subject to a barometric error, pressure errors. Okay, so true altitude of aircraft depends on atmospheric pressure and temperature and temperature. So if atmosphere is warmer than ISA, colder than ISA, again your altimeter will be subject to temperature errors. Now here, you're you are flying at you are flying at 16,000 feet. Now ISA temperature at 16,000 feet is equal to 15 degrees Celsius minus 2 into 16,000. So 15 minus 32. What is 15 minus 32? It is minus 17 degree Celsius. Okay. And what is the outside air temperature or ambient temperature given to you? It is minus 30 degrees Celsius. So that means ISA temperature should be, according to ISA, the temperature should be minus 17. But actually the temperature is minus 30. That means it is colder than the expectations. So ISA deviation will be, ISA deviation is equal to outside air temperature minus ISA temperature. Outside air temperature is minus 30 degrees Celsius. ISA temperature is minus 70. Therefore, ISA deviation is equal to minus 30 plus 17. So minus 30 plus 17 is minus 13 degree Celsius. That means outside temperature, atmospheric temperature is colder than ISA by minus 13 degrees Celsius. Now the true altitude of your aircraft will be equal to indicated altitude minus temperature error correction. Since you are flying in cold air mass, colder than ISA air mass, the true altitude of your aircraft will be less than the indicated altitude. Correct? So indicated altitude is 16,000 feet minus temperature error correction. So this we will calculate now. What is it? Your ISA deviation is minus 13. So the correction, temperature error correction you will apply will be equal to 4 multiplied by ISA deviation multiplied by per 1000 feet. So 4 multiplied by ISA deviation is minus 13 multiplied by per 1000 feet. How many thousand feet we are flying at? 16,000. So 4 into 13 into 16 is minus 832 feet. Okay, minus 832 feet. So right here minus I have already written. So minus 832. So 16,000 minus 832 is 15,168 feet. So your true altitude is 15,168. The closest option here is option alpha, 15,200 feet. This is how you do it. Next, what will happen to indicated altitude if you are flying in level flight and you pass into a warmer air mass? Okay, so let's say you are flying in this particular atmospheric layer, which is colder than ISA, and from this atmospheric layer now you enter a warmer layer, warmer air mass, That means it is warmer than ISA. So you are flying level at a constant altitude. Okay, like this. Okay, at a constant altitude of, let's say, 10,000 feet. So you are changing air masses. You were flying in cold air mass, now you have entered warm air mass. So what will happen in warm air mass, I wrote here, in when you are flying in warmer than ISA air mass, the true altitude of your aircraft is more than indicated altitude. True altitude of your aircraft is more than indicated altitude. So true altitude will be more than indicated altitude. That means your altimeter may be indicating to you that you are flying at 10,000 feet. Your true altitude. In reality, your true altitude will be more than that. Let's say 12,000 feet. True altitude will be always more than the indicated altitude. So what will happen to indicated altitude if aircraft in level flight passes into warm air mass? They have asked us what happens to indicated altitude. Indicated altitude will under indicate. Okay, as you can see here, altitude indicated is 10,000, true is 12,000. So ultimate altitude indicated to you is less than the true altitude. So under indication is happening. Radio altimeter can be defined as a ground radio aid used to measure true height of aircraft. So ground aid used to measure true altitude of aircraft. Self-contained on-board used to measure true height of aircraft. So the correct answer here is option Charlie. Your radio altimeter is available on board. So you do not require any corresponding ground equipment to be available on the ground. So it is a self-contained independent airborne instrument. So available on board, right? And it indicates height of aircraft above the ground, above the ground, below, above the ground, below. Remember this, okay? So self-contained onboard aid and true height, not true altitude, true height. Next. In low altitude radio altimeters height measurement, it is based upon what principle? A triangular amplitude modulation wave for which modulation phase shift between transmitted and received waves after reflection is measured. A frequency modulated wave for which frequency variation between the transmitted and the reflected wave is measured. A pulse transmission for which time between transmission and reception is measured. So the correct answer is option Bravo. Radio altimeter sends out a frequency modulated wave towards the ground surface. That wave gets reflected and comes back. So the transmitted frequency is different from the reception or received frequency. So your radio altimeter waves works on frequency modulation wave, not pulse. It doesn't send pulses, it sends continuous wave. And this is amplitude modulation, that is also wrong. It is frequency modulated. So remember this. So this concludes our lecture. I hope you have understood all the 10 questions that I have done in this video lecture. Best of luck. If you have any doubt, comments, feedback, let me know in the comment box of this video lecture. And I request you all to share this channel, this particular video lecture with your friends who are also preparing for the exam. Don't forget to subscribe to this channel and hit the like button if you have liked this video lecture.